So welcome, this is CAIE paper of June 2006 M1 paper. We shall solve all the questions. So let us start from the first question. A car of mass 1200 kgs is moving with a constant acceleration of a meters per second. A car speed increases from 10 meters per second to 25 meters per second, traveling a distance of 525 meters. So u is equal to 10 meters per second initial velocity, final velocity is 25 meters per second, distance is 525 meters, and the acceleration is unknown. So I use the formula v square is equal to u square plus 2as. 25 square is equal to 10 square plus 2 times a times s is 525. From that I make a as a subject. 25 square minus 10 square by 2 times 525, which gives me a as 0.5 meters per second square. A very simple part. Coming to the second part. A car engine exerts a constant driving force of 900 newtons. Resistance of the motion is constant, equal to R. Find R. For these kind of formulas, I would have told you one formula. What is the key of questions? One formula is forward force minus backward force is equal to MA. So very simple formula. The forward force is driving force, which is 900. Backward force is R. M is 1200 times A. So 900 minus R, A just now we have got it as 0.5. Now plug in from there and get the value of R as 300 newtons. That's going to be the answer. Question number 2. A motorcycle starts from rest. So initial velocity is 0. Travels in a straight line until he comes to rest. So final velocity is also equal to 0. Then he's up. The velocity of the motorcycle is t seconds after leaving A is v meters per second, and v follows this formula. V is equal to t minus 0.01 t square. So at two instances the velocity is 0. So we shall find the time. At what instances the velocity is 0. So 0 is equal to, I take t common, 1 minus 0.01 t. From there I get two answers. T is equal to 0, which is at the start. That's correct. So another answer will give me the time when it is at the end. So 1 is equal to 0.01 t. So t is equal to 100 seconds. So it took 100 seconds to travel from A to B. Then he's asking find the distance. So when the distance is asked, when I know the velocity, so I'm going to use the integration. Integral with respect to dt, integral dt. So that becomes distance t square by 2 minus 0.01 t cube by 3. But I need to apply the limits. What are the limits? It's starting from 0 to 100. 0 to 100 because it took 100 seconds. So I apply the limits 0 to 100. So when I apply the limits, 100 square by 2 minus 0.01 upon 3, 100 cube minus 0 square by 2 minus 0.01 upon 3, 0 cube. So when I solve it out, I'm directly writing it at the answer in 3 significant figures, which is 1670 meters. This question now, whenever you see this question, first we need to resolve the forces. So let us resolve this first force F into one horizontal and one vertical. We have to resolve the forces into horizontal and vertical. So this horizontal will be always cosine, half cosine 50, f cosine 50, f sine 50. Now coming to the another f is there, another force F. So I resolve, let it be in blue color, I resolve one downwards and one towards the left side. So f cos 20, then f sine 20. So now the body is in equilibrium. Whenever the body is in equilibrium, upward force is equal to downward force. Remember, upward force is equal to downward force. Downward force. So the upward force is f sine 50. The downward force will be f sine 20 and 12. F sine 20 plus 12. Then I bring all the terms on f on one side. F sine 50 minus f sine 20 is equal to 12. From there I take f common. Sine 50 minus sine 20 is equal to 12. So I need to get the value of f. F is equal to 12 upon sine 50 minus sine 20. So when I solve it out by using the calculator, directly I'm writing the answer, which is 28.3. Now I need to get the value of g. For that, I see that right side force is equal to left side force because it is in equilibrium. Right side force is equal to left side force. So the right side force is g and the left side force is f cos 20 plus f sine 50. Now plug in the values of f cos 50. So plug in the value of f, which was 28.3 cos 20 plus 28.3 cos 50. So simplify, you should be getting the answer 44.8. Question number 4. The diagram shows the velocity time graph motion of a small stone which falls vertically from the rest above the surface of a liquid. So let us draw a rough diagram. It's like this. This is a liquid. The body is falling from here, from the top, a height of h. I don't know what is the height of h. So let me do in different colors. So body is here and it is falling from a height of h. This height h I have to calculate, and if the stone hits the liquid surface with v 7 meters per second, over here it is 7 meters per second at t is equal to 0.7, but it reaches the bottom with 0.5 meters per second at t equal to 1.2. Find the height a of a above the surface of the liquid. So there is a body a. So what should I do? So what am I going to do it is, in the velocity time graph, the area gives me the distance. So this is the distance which is above the liquid. This red color part is the distance which is above the liquid. So I need to find the area of this triangle. How do I find the area of a triangle? Area of a triangle formula we know. It is half base into height. Area is equal to half base times height. So what is the base? Base is 0.7 and height is 7. So when I simplify this, it is 2.45 meters. So what is the height? 2.45 meters is going to be the height. Next part is called as find the depth of the liquid container. So the depth of the liquid container, once again I do it out within blue color now. So this is the depth of the liquid container, the blue color one. So I have to find the area of this one. So it's a trapezium. So I find the area of a trapezium. Okay, so let me do that. Okay, so area of a trapezium is equal to half times a plus b times h. So half times a and b are the parallel sides. This is a, this is b. So it is 5 and 7. 5 plus 7 times height. What is the height? Distance between them. Distance between them is 0.5. So which becomes 12 divided by 4, which becomes 3 meters. So depth of the liquid is 3 meters. In the second part, what is being asked? Find the deceleration of the stone when it is been moving. So deceleration of the stone. So we have to find it out, the deceleration of the stone. So this part is the decelerating motion. So I have to find the deceleration of the stone. So we know my final velocity was 5 meters per second. Initial velocity was 7 meters per second. Time was 0.5 seconds. So we use v is equal to u plus at. 5 is equal to 7 plus a times 0.5. So minus 2 is equal to a times 0.5. A is equal to minus 4 meter per second square. So most of the students will leave it out over here, but no, he is asking deceleration, not acceleration. We got acceleration as minus 4, so deceleration is plus 4 meter per second square. That care has to be taken, otherwise you tend to lose 1 mark. Next, Given that the resistance of the motion is of magnitude 0.7 newtons, find the mass of the stone. So as such, we have done in the previous sum also, very simple. Forward force minus backward force is equal to ma. So forward force, where is the forward force? It is falling because of its weight. What is its weight? Minus backward force, so is equal to ma. So it is falling because of its weight, which is mg, minus backward force is resistance force with 0.7. M is nothing but what we have to find it out, and a is acceleration minus 4, not deceleration. We should take the acceleration minus 4. So from there, mg is 10 plus m times 4 is equal to 0.7. So 14m is equal to 0.7. M is equal to 0.7 upon 14, which is 0.05 kgs. This is going to be the answer for question number 4. Question number 5. The particles P and Q, it's repeated twice, okay, no problem. The particles P and Q are attached to the opposite ends of a light inextensible string. P is at a rest on a rough horizontal plane. The string passes over a small smooth pulley which is fixed at an edge of a table. Q hangs vertically below. The force exerted on the string by the pulley has a magnitude of 4√2 newtons. The coefficient of friction between the P and the table is 0.8. Show that the tension in the string is 4 newtons and state the mass of the Q. So what is being asked? Now it is been told that the force exerted on the string by the pulley is 4√2 newtons. So the force is 4√2 newtons. Now remember, there is a formula to find the tension. This is tension over here towards the pulley. There is a tension over here the pulley. Then the two tensions are acting towards the pulley. See carefully, the tensions are acting towards the pulley. Now there is a formula. If at all I want to know force exerted, I'm writing clearly, very clearly. See, force exerted on the string will be always what it says. Now we have is over here, it is 4√2 newtons. Now I want to know the tension. The tension formula will be this force cos theta by 2. What is theta? The angle between those two tensions. Whatever is the angle between those two tensions, over here it is 90 degrees. So T is equal to F cos 90 by 2, which is cos 45. So tension is equal to F is 4√2, cos 45 is 1 upon √2. So tension is equal to 4 newtons. So see carefully, that is a formula. Tension is equal to F cos theta by 2, the force exerted by the pulley, times cos of the theta by 2, whatever is the theta between those two tensions. So the theta is 90 degrees over here, 90 by 2 is 45. So that is to show that the tension is 4 newtons. Now I need to prove that, or I need to find the mass. Okay, in case of the first mass of the Q, mass of Q we don't know. So we know that again, forward force minus backward force is equal to ma. Forward force minus backward force is equal to ma. So the forward force, it is falling down because of its weight, mg, minus backward force is tension, is equal to, it is in equilibrium, I think. So you need to read that question carefully. It is in equilibrium. It is not is falling. It should be in equilibrium. Is at rest, right? So you can see that it is at rest. So is equal to ma, so it has to be equal to 0. So tension is equal to mg. So tension is 4, m I don't know, g is 10, so m is equal to 0.4 kgs. That is the mass of the particle Q. Now coming to the next part. Given that P is on a point of slipping, find its mass P. So P is on the point of slipping. So when it is going towards the left, the friction will be acting towards the right, mu r. R is its weight, so this is mg. As the weight of P has been given, find its mass, so its weight has not been given. MP, we take it as mpg, and it is balanced with R. So whenever it is moving towards the left, the friction will be acting towards the right. So now for P. Forward force is tension, backward force is mu r is equal to mp of A. Now for the tension is 4 newtons minus the backward force is mu r. So he given mu value. The mu value is 0.8. 0.8 and R value is mg. So mp times g is 10 is equal to 0 because it is at rest. So from there I get mp value as 4 divided by 0.8 times 10, which is again 0.5 kgs. So that is the mass of P. A particle of mass 0.1 kgs is now attached to Q. So now what am I doing? An additional mass of 0.1 kgs is being attached to Q. So 0.1 g also acts downwards. Now the total weight will be what? So now this total weight will be 0.4 plus 0.1, which is 0.5 g, which will be acting downwards. Okay. So what is he asking? Find the tension in the string while they are in the motion. So now there will be a new tension. There will be no the same tension. Let this new tension will be T in green color. Okay, T in green color. So what should I do? So forward force minus backward force is equal to MA. So now Q is moving downwards for Q. The forward force is 0.5 G minus the tension T is equal to the total mass is 0.5 A for Q. For P, the forward force is tension minus backward force is mu R. Mu R. So mu is 0.8, R remains the same, which is 0.5 G, because mass of P was 0.5 is equal to MA, 0.5 A. This time they are moving, so therefore acceleration is not equal to 0. From there, what I can do it out is, I will do the subtraction of these two equations. If I subtract these two equations, minus plus minus 0.5, 0.5 gets cancels, 0.5 G minus 2T plus 0.8 times 0.5 G is equal to 0. So from there, 2T is equal to 0.5 G is 5, then plus 0.8 times 0.5 G is again 5, so this is 4 plus 5 9, so 2T is equal to 9, T is equal to 9 upon 2, which is 4.5 newtons. That is going to be the answer for question number 5. Question number 6. A block of mass 50 kgs is pulled up a straight hill and passes through points A and B with a speed 7 meters per second and 3 meters per second respectively. Distance AB is 200 meters, B is 15 meters higher than A. So let us draw the diagram. So B, A. So B is 15 meters above A. So this distance is 15 meters higher, and this distance is 200 meters. Then the velocity at A was 7 meters per second. Over here the velocity is 7 meters per second. Over here the velocity is 5 meters per second. Find the loss in the kinetic energy. Very simple question. Loss in kinetic energy. Loss in kinetic energy is final kinetic energy minus initial kinetic energy. Final minus initial kinetic energy. Final kinetic energy half times mass, as the mass has been given, which is 50 kgs. 50 times 5 square, is it 5 or 3? It's 3, not 5, it's 3. So 3 square minus half times 50 times 7 square. So I get a, because he's asking loss in the kinetic energy, so therefore what am I doing it out is I am finding it out the change in kinetic energy. Change in kinetic energy, which gives me negative 1000 joules. But he's asking loss in kinetic energy. Loss in kinetic energy will be always a positive quantity, so therefore 1000 joules. Next, the gain in the potential energy. What is the gain in the potential energy being asked? So gain in the potential energy, simple, gain in potential energy. So I find it out the change in potential energy. Change in potential energy will be equal to final potential energy minus initial potential energy minus initial potential energy. Final potential energy is mgh. M is 50, g is 10, h how much height it has risen, 15. Initially let it be considered as 0, so that it becomes 7500 joules. So this is only gain in kinetic energy is equal to 7500 joules. Now the pulling force on the block has a magnitude of 45 newtons, acts at an angle alpha upwards the hill. Find the value of alpha, that is for the fourth part. For the third part, the resistance of the motion of the block is 7.5 newtons. The resistance of the motion is 7.5 newtons. Find the work done by the pulling force acting on the block. So that's a 2 marks question. So we have to find the work done acting on the block. Total work done. So we use a formula. What formula we use? Total work done is equal to delta KE plus delta PE plus work done against friction, TWD. What is TWD? Total work done. What is WDF? Work done against friction. Work done against friction. So total work done is being asked. So delta KE. Delta KE means we have to find it out the loss in kinetic energy. So delta KE, that's the reason delta KE is change in kinetic energy. So we use minus 1000. That's the reason I have found it out, always change. Plus delta PE. This is also change in potential energy. Change in potential energy is 7500. Plus work done against friction, which is force times distance. What is the frictional force has been given? The frictional force is 7.5 and the distance is 2000. So it is 7.5 times 2000. So when I simplify this, I will be getting the answer as 8000 joules. So therefore, whenever I am using this formula, we use delta KE, means change in kinetic energy. So final minus initial. So you have to understand that we use delta KE. That's the reason in the starting of this sum I have found it out delta KE. Delta PE means change in potential energy. Work done against friction is force times distance. Force is 7.5, distance is 200 meters, not 2000, 200 meters. So let me write that one neatly, 200. Then I will be getting the answer as 8000 joules. Now coming to the last part of the question. The pulling force acts on a body, has a constant force of 45 newtons acting at an angle alpha. Find the value of alpha. So where is that? There is a pulling force acts on a body at an angle alpha. So this is the pulling force alpha. This angle is alpha. So my forward, so resolve that one. It will be resolved into forward force, which is, this is 45, right? So 45 cos alpha. 45 cos alpha. The force will be 45 cos alpha. And there will be one more force which is there, 45 sin alpha. But it is moving basically only because of 45 cos alpha. Just now we have done that. Work done is equal to 8000 joules. So this 8000 work done is equal to force times distance. So what is the force? The force is 45 cos alpha, and the distance it has moved is 200 meters. From there I get cos alpha is equal to 8000 divided by 45 times 200. So alpha is equal to cos inverse of 8000 divided by 45 times 200. So alpha is equal to 27.3. That's going to be the answer. Question number 7, the last question. Two particles P and Q move on a graded slope of a smooth inclined plane, so no friction. The particles start at rest at the same instant and from the same point, each with a speed 1.3. Initially P moves down the plane and Q moves up the plane. So let us draw the diagram carefully. So there are two particles. This is particle P, there will be particle P, and there may be another particle Q. They are at the same position. So we can say that it is like this. Okay, I can consider like this because they are at the same position. I can consider one inside the other, but it's not possible to understand, right? So I'm thinking that it is over here. So they are, or else I can consider particle Q, which is blue in color. They are at the same position. What is he telling? The particles start from rest. At the same, the particles start at the same instant from the same point, each with a speed of 1.3. P moves down and Q moves up. So Q is moving upwards, whereas P is moving downwards. Okay, so see the color combination. Okay, then the distance between the particles t seconds after that move is d. Show that d is equal to 2.6. So we have to show that the d is equal to 2.6. How should I be showing the d is equal to 2.6? Two particles. Now what am I going to do? P and Q. Let me do P and another particle is Q. So two different colors. Both are starting with initial velocity how much? 1.3. So over here also initial velocity is 1.3. Now the time is same for both. T equal to T equal to T. Okay, so now I have to find the distance between them when they are after t seconds. So let the acceleration be a, because it is on the same plane, right? So the acceleration has to be the same. Okay, so what will be happening? So s is equal to ut plus half at square. I use a formula, common formula for both of them. What is that common formula I'll be going to use? S is equal to ut plus half at square. Okay, so if I consider, listen carefully, if I consider P is moving down, which is positive quantity, so my S will be equal to 1.3t plus half at square. Okay, but if at all I consider for Q, which is going upwards, it will be minus 1.3t plus half at square. So remember that acceleration is going to be the same. So let me write over here, acceleration, whether it is going up or down, it is going to be the same because it is on the same inclined plane. So the distance formula, s is equal to ut plus half at square, has been taken. Because velocity is a vector quantity, if at all you are considering going upwards is positive, then going downwards will be negative. Now the distance, this is the distance moved by P and this is the distance moved by Q. So PQ will be equal to, what am I going to do? SP minus SQ. So 1.3t plus half at square minus 1.3t plus half at square. So when I simplify that, I get 2.6t. That's what is being asked, which is distance d. Now next part of the question. What is the next part of the question? T is equal to 2.5. Difference in the vertical height is 1.6 meters. The Acceleration of the particle down the plane. 3 marks question. So he is asking us to find it out, the acceleration down the plane. So let us redraw the diagram. Now the particles came over here. P came down. Okay, it's not the circle. P came down and Q came up. Okay, so what else has been told? It is told that the vertical height between the particles is 1.6. This vertical height is 1.6. Okay, and this distance was 2.6 t, right? And t is 2.5. So this distance will become 2.6 times 2.5. So I'm going to find the angle alpha. Sine alpha. Sine alpha is equal to opposite side by hypotenuse, 2.6 times 2.5. I got the value of sine alpha. Now what is being asked? He's not asking alpha. Find the acceleration down the plane. So as such, we know that acceleration will be always g sine alpha. G sine alpha across down the plane will be g sine alpha. G is 10, sine alpha is 1.6 times 2.6 times 2.5. So this one directly I'm going to write 2.46 meters per second square. So acceleration down the plane will be always, remember the formula, A is equal to g sine alpha. Now finally what is being asked? Distance traveled by P and P when Q hits at its highest point. Q hits at its highest point. What does it mean? Means Q hits at its highest point means its velocity should be equal to 0. Its velocity should be equal to 0. When is that velocity is equal to 0? So for Q, the final velocity should be equal to 0. Initial velocity we have thought that it is going up minus 1.3. Acceleration just now we have found it as 2.46. How much time it will take we don't know. So we use the formula V is equal to U plus AT. 0 is equal to minus 1.3 times 2.46 times T. From there I get the T value as, we'll take full calculator display because it is a part of the calculations. So time is equal to 0.528125. So it took this much time to go up and stop there. Now so P also would have been traveled this much distance. So distance traveled by P is equal to S is equal to UT plus half AT square. So U is 1.3. For P it is positive 1.3. T is 0.528125 plus half times A is 2.46 times 0.528125 whole square. This distance is the distance traveled by P. So when I simplify it, I quickly take the calculator, and it's a long calculations. Let me do that one. So it is 1.3 times 0.528125 plus half times 2.46 times 0.528125 whole square. So when I simplify in three significant figures, it becomes 1.03 meters. That's going to be the final answer for question number 3 or question number 7. That completes the entire paper. Thank you for watching. See you in the next paper. Bye for now.